Example 8, Chapter 8. Suppose that 1 kilogram of saturated vapor at condensed to saturated liquid in a constant pressure process. By heat transfer to the surrounding air, which is at 25 degrees centigrade, Kelvin or degrees centigrade. What is the net increase in entropy of the water plus surrounding? The net entropy of the water plus surrounding. For the control mass, at first we should show on the PV diagram for example from saturated water vapor, point 1, is condensed to a saturated liquid at constant pressure 2, where TS diagram we have at first saturated vapor and a constant pressure, point 1, saturated vapor to saturated liquid. Point 2nd, and also we have two other processes here, 3 and 4. The temperature is and the temperature of the In this equation we have a control mass of water with T equals to Kelvin. The heat Q to surrounding at T equals to 25 degrees centigrade or T0. For the change from saturated liquid is HF, HG or SG, SF, S. SFG. The delta S control mass equals to minus M SFG for 1 kilogram minus SFG from table E11. We can obtain the delta S control mass We have also a Q2 surrounding equals to the change in the entropy. Because we don't have, this comes from the first law. Stage 1 and stage 2. Inlet and outlet. There is an inlet and outlet, so and U plus PV is HFG, PE and E approximately 0. W also equals to 0 in this equation, and Q2 surrounding can be calculated from MHFG so delta S on T, temperature is T0, 25 degrees centigrade, which is equals to, converted to the kilograms. Delta S This increase in entropy is accordance with the principle of increase of entropy and tell us, as does our experience, that this process can take place. It is interesting to note how this heat transfer from the water to surrounding may have taken place reversibly. Suppose that an engine operated at the Carnot cycle received heat from the water and rejected heat to the surrounding, as this picture. water W, a Carnot cycle. In this case, delta S control volume is control mass is equals to previous because the net Q goes to the surrounding at 25 degrees centigrade with the same change in the state. The increase of the entropy of water is equal to the increase in the entropy of surrounding because there is a Carnot cycle. And now we can calculate Q to surrounding is T0 delta S for reversible process. Delta S total equals to 0, so delta S generation delta S which is Q2 surrounding. In this case, Q2 surrounding is QL and QH equals to the previous calculated QH from water at irreversible process. QH minus QL can be calculated.